1.6. A line emission spectrum is formed when an excited atom moves from a, right, let's have a look, higher to a lower energy level and releases energy. Higher to a lower energy level and absorbs energy. Lower to a higher energy level and releases energy. Lower to a higher energy level and absorbs energy. Right, let's go back to the statement. As I'm saying, statement carries a lot of information. A line emission spectrum is formed when excited atom. Excited. So what do we mean by that? Remember, when you've got an atom, you've got an atom there, and we've got the nucleus, remember, inside, and you may have different energy levels around the nucleus there. Remember what an energy level is. It's just, a position where there is a likelihood of getting electrons of certain energy. Those of similar energy will be in the same energy level. But now, the more the energy the electrons have, then they will get to a higher energy level. So the one closest to the nucleus is the one with the lowest energy level. And then as you go further from the nucleus, you are having electrons with more energy. So this is 1, and then this is 2. 1 is for first energy level, 2 second energy level, just like that. Okay. Now we say is formed when an excited atom moves from what? Right. And then the other thing that is important that you have to look at is this part. A line emission spectrum. This part. This is also where you've got your answer. Emission, it emits. Now, something is given out. It emits. So when it emits, so it means something is given out. So energy, this time, let's have a look at what is said there. Higher to a lower energy level and releases. So can you see? There's something about releasing, emitting, releasing. So release there, I will think, yes, this part is highly possible. Where is the release again? This other part, but which one ultimately? Right. So now we say when an excited atom moves from what? From a higher to a lower, or from a lower to a higher energy level? Let's have a look at that. Can it be from this to that, or can it be from that to that? Right? Remember, normally each and every atom is said to be in its normal, or we say ground state. But the minute it gets a certain energy, it becomes excited. Like human beings, when you especially you kids, when you are still at home, at school, after eating, when you come and then you get to class, after break is a mission, because you are so excited, you want to do this, you want to do that, So that is because you've got a lot of energy. You want to make use of that energy. Yeah? Right. So in this case, this electron has got to absorb energy first. And then it will be able to go to an energy level with a more energy state. So in this case, it will go from there to there. It's fine. But you needed energy to give to this electron. And this electron is not at its normal state. Each and everything has to be at its ground state. Even a human being has got to be at the person's normal state, not the excited state. It is not okay that way. Right. Then from there, this, for it to go back to the ground state, it has to release energy, guys. So therefore, it cannot release energy from a lower energy level to a higher energy level. No, it must be the other way around. It must be from a higher one to a lower one. So let's have a look at our two options. So higher to a lower and releases energy. Lower to a higher and releases energy. No ways. So this one cannot be the answer. It should be this one, from higher to lower, and it is releasing that energy. And that is why you find that it will release that. In most cases, it releases that in the form of a certain light. You find that sometimes you see yellow lights, you see blue, violet lights. That is because of the energy that is being released by those electrons from that particular type of an element that is in use.